Okay, now thank you for inviting me along. It's a great pleasure to address a wider European audience. And I just wish I could be there, that we could all be together in a room. But anyway, this is quite a good way of doing it, because a lot of what I'm teaching is very visual. And I think that's one of the reasons for success on social media. I can easily post very pretty images. There we go, right. But one thing I never see, or hardly ever see, is my soil. So sometimes I'll dig a hole just to have a look. And in the case on the left, that was actually in my previous garden, which was clay. And at 45 centimeters down, we found a lovely array of channels, holes made by earthworms mostly. Now that's just the bit we can see. But I was reassured, because that soil had been in bad condition when I took it over 11 years before that. And with parsnips, you know, it used to be said, people are coming around to this now. The no-dig was, when I started 40 years ago, it was unheard of pretty much. It had been around. I mean, it's not me who's invented no-dig. I've just taken it to a more common level, I feel, made it more accessible, because it's basically common sense. And you can see how that parsnip has gone down without any problem at all. Its problem is actually getting it out. And so this is to give you an idea of what my soil is currently at Homemakers. Of all the 4 gardens I've had since 1982, this is the best soil I've had, and it's also the most level site, which means it's very easy to work as well. And you can see it's going towards clay underneath a nice silty loam topsoil. And this is how we maintain fertility every year. 1 spreading of compost, around 2.5–3 centimeters. It's a very hard thing to measure that, and I think I've misled people in the past. I've often said 5 centimeters, because that's what it looks like when you put it on sometimes, and also that could be the depth or height of the biggest lump. But the average depth, especially, I'll measure it after maybe 2 or 3 weeks. It might have rained a bit, and then it settles, and that's how much we're putting on. So just to be clear on that, and I find that it's about as much as disappears in a year. Not literally disappears, but gets eaten by soil life. And so you then end up with seeing your soil surface again, which with every year that passes gets darker. And then in the pathways, we're putting wood chip. I didn't used to do this, but I've come more and more to appreciate the fungal quality that comes with woody material. So my compost also is quite woody. We're putting more wood in the compost heaps. And we're achieving a very high level of fertility, but not excessive. And it's easily enough to grow 2 plantings a year. So that's photograph in September is entirely crops that were planted since June, and they replaced something that had already grown. For instance, even the climbing beans were after spinach, and almost none of those beds have had any compost in the last 10 months. There's 1 or 2 that might have had it in the summer if we had missed the spreading of compost the previous autumn. So the idea is it's the old-fashioned organic mantra, feeding the soil, but more precisely, that's feeding the soil life, and they do the work. It's allowing them to do the work. That's the beauty of no-dig. You know, you don't actually need to know all that, but if you do, it's really interesting. And for a long time, I didn't know any of it really. It just, for me, it was an instinctive thing. I just could not see the point of stirring up the soil. And then I noticed that things grew really well if I just left it alone. And then when I started out, I was mulching with hay and following Ruth Stout in the USA, more of a gardener than a market gardener. And then I found lots of slug damage. So that's when I started using compost. That was only 6 months after I began. So I've been adapting all the time. And I would say it's a pretty nice formula now going forwards in this climate. And actually with YouTube, I get feedback from all over the world. And I'm encouraged how positive it is, doing very similar to this, using compost from the Philippines, from Brazil, from Arizona, from southern India, really quite dry climates, even tropical climates. And this method seems to be very replicable with just slight variations. I'm actually been asked to give some talks in South Africa next month. That's in live. They're flying me out there. So I'm very interested to see how that goes. And
Charles, can I just, I had a comment, because we have an international audience, could you perhaps speak a little bit more slowly?
Yeah, you did say
that
that, sorry, I forgot. Okay. So yeah, this is one of the gorgeous things we see with no-dig. mycelial network occasionally fruiting. And in my beds, this is perhaps the most common mushroom we see. I think it's a kind of lepiota. It's the naming of mushrooms is difficult because a lot of the mycological classifications have changed in the last 10 years. But the net effect in the soil is all those mycelial threads and a lot of white soil. So we have some areas here that are really quite white. It's great for plants, and that's the result after autumn rain. So in a damp climate, or after it's been raining, we quite often see that sort of thing going on. And that suggests basically there's a decent amount of decaying wood near the surface. And it's not necessarily telling you you've got loads of mycorrhizal fungi, for example, but it's a sign. If there's some fungi there, there's probably lots of others as well. And I'm very happy to see that. Those Swedes, by the way, are an example of how we look after plants, taking off the lower leaves. And that's to keep the ground tidy and then reduce slugs. I get very few slugs with no-dig, I find, probably because we're allowing the ground beetles to thrive. We're not damaging any of the predators, and they eat the slug eggs, for example. Here's a close-up of mycelial breakdown, 400 times magnification. I've started working with microbiologists now, and that is so interesting. And so they'll bring their microscope along to homemakers and see what they can find. And this was just on a piece of decaying wood. So beautiful. I just love to know or imagine all of this going on out of sight, mostly. So important part of this for growing, I'm very much a grower, so this is commercial production. Even on just a third of an acre, we're selling well over £20,000 worth of vegetables in a year. And that also, we produce a lot for courses that I run here and things. So it's pretty high output per acre. And for that, I'm using around 12 tons. Oh, I better talk metric here. Per hectare, it would be a lot. It would be close to 80 tons a hectare, probably, of compost. And I have a feeling some of you might be throwing your hands up in horror at this, because it might even be higher than the EU limit. And I've just remembered that this presentation is being recorded. So hello, EU Commissioner. And well, the point being, though, that the laws about leaching of nutrients are framed for cow slurry and not for composting, like with that slide I showed you before. The nutrients in compost don't leach. They're stable, they're water insoluble. So making this compost is an important part of what I do. And this is a very simple way. This is great for like British allotments and smaller gardens, just using pallets, and quick, cheap to make. It's just 8 wires and 4 pieces of wood, and you've got your heap. So 2 wires on each corner. There's no cardboard at the bottom of any heap, but we put cardboard around the edge just because this area these heaps are in actually was 6 months earlier was bindweed, brambles, couch grass, nettles, thistles, everything. But the compost heap itself is like a good mulch, and the cardboard does the rest around the edge. And then when we want to open one of those up, we can just undo 2 wires, and you've got a loose edge. The pallet swings open like a door. And we fill the outer bays only, and they go into the middle. So that's the result by October, from starting in April, for example, 6 months later. And both of the outside heaps have gone into that middle heap. And you can see there's quite a few bits of wood there. There were quite a few toads as well, some mice, everything you get in a compost heap, just loads of life, basically. And that was enough probably to spread 6 or 7 of my beds, maybe 12 meters long. So we're putting it on, I think not a lot. I think we're using less compost actually per acre than traditional market gardeners would have used in the last century, when they had horse manure and all of that kind of thing to give it a historical context. In fact, I read something on YouTube, so University of Nebraska in 1870, and they were recommending 140 tons an acre of cow manure every year for growing vegetables, to give you an idea. I wouldn't do that, but that's where it was before artificial fertilizer. And so making compost, I'm using, to get enough, I'm using whatever I can get my hands on, including quite a bit of wood. And I've got a shredder, a trusty Bosch electric shredder. In fact, if we use that when the sun's out, I've got solar panels, so that helps to close the loop a bit. And it's not too noisy. That's some apple prunings there. So I'm looking always to balance the green and brown, and putting in more brown than I used to before I had this shredder. And then for the heaps, we do just 1 ton. And I find that's enough. I reckon if you do more than 1 ton, then it's what we call the law of diminishing returns. And doing this 1 ton means we get a nicer product, takes about 2 hours. And then you'll get that 2 hours back when you come spread the compost, because it's nicer and quicker to use. And it's often between 6 and 8 months old, up to a year. For me, the best value of compost is in that time window, 8 to 12 months, probably not more than 18. You start to lose volume in particular. And then we're looking at 1 or 2 other ways of making compost as well. So for example, some of you might have heard of this one, a professor in Texas, Johnson, and his wife Sue, and they've been experimenting with aerobic wood chip. So using drain pipes like that, which you then take out after you've filled the heap, and the outer container is weld mesh. You can reuse all of that time and again. And it's on top of a pallet where you've got airflow coming in the bottom. So the idea is it's aerobic decomposition of wood. So we're comparing this with heaps that are open to the elements, and I have to say that so far I'm not seeing much difference for all that extra work. But I'd put this up just as a thought-provoking idea, and to show that, you know, we're always trying new things here, and sometimes they don't work. If they do, though, it's great. And one of the things I'm doing always is a trial of my dig and no-dig comparison beds. So every year in December, I dig the bed that's on the left in each photograph. So each photograph has 2 beds side by side. The left-hand one is the dig bed, the right-hand one is no-dig. They both have the same amount of compost. They're both planted on the same day at the same time. They're both harvested at the same time. All harvests are recorded for kitchen-ready trimmed vegetables. That's what we record as the weight of harvest. And there's 2 plantings a year on this bed. And for example, there you can see the May plantings on the left and the summer plantings on the right. Sorry, when I said May plantings, I should have said March, because the photograph is in May. So we have the spring vegetables, then we have the summer and autumn vegetables. And there's very little ground preparation between doing that. Just rake it level if needed even. And most of the weeding is on the dig bed. And the harvest over 9 years now since I arrived at Homemakers are there. You can access this image on my website. There's a page all about trials with a lot of this data on, free to anyone who wants to have a look. And you can see a reasonably consistent pattern there of the no-dig bed being higher harvest for less time needed, basically. Many people ask what the devil went on in 2017 and 18. It's just the weather. We had a lovely year and then we had a dry year. This is fascinating, where you can see the difference in soil structure. So the dig bed on the left, no dig on the right. And the way I would explain this on the right is where you've got the humic glues from glomalin, which is the sticky substance you get on the outside of mycorrhizal fungi. And as those mycelia thread their way through the soil, they leave behind them a sheath or a skin which is sticky, and that's called glomalin. Was only discovered in 1996 by Sarah Wright in the States, and it's now reckoned that's a really important part of soil. I mean, 25 years ago it wasn't even known. You know, this is how my take of science is, that it's a contemporary snapshot, and that's all. You know, it's evolving all the time. You never reach the end with science. And so you've got to always bear that in mind. You know, there's always lots of working hypotheses, really. But glomalin does seem to have an important role in aggregation of soil particles, which gives you stable structure. And that's the lovely crumbly soil you get with no dig. And there is another comparison between dig on the left and no dig on the right by a different guy with a different microscope at a different time. And very similar result. And also he pointed out, if you look in the middle of the photograph on the right, you can see what's called a diatom, and that's the origin of diatomaceous earth, the lovely silica-rich earthy substance which has fantastic properties against pests. And then diatoms don't occur much in soil, but when you see them, that's a good sign. And they oxygenate. They're taking carbon dioxide and turning it into oxygen. There's also an amoeba there. There's so much going on in soil, fascinating. And then this is a scientist I'm working with, still waiting for the results, but she's got a whole year of results. And one very simple thing she did was putting calico or cotton strips in both of those beds and seeing how quickly they degraded as a sign of microbial life. Anyone could do that. And it was quite a bit more degradation in the no-dig, as you might imagine, but it was just good to see. And then here's another trial we're doing, which I call the 3-strip trial. So you won't have time to absorb all this information here, but again, it's on my website. So you just click on that page. And what I was really trying to find out here was more than anything, the difference between strip 1 and strip 2, because strip 1 is forked and strip 2 is no-dig. They both have the same compost. Strip 3 is also no-dig and has different compost. And the main difference we see over 6-7 years of doing this now, 8 years even, is that strip 1, that beds that are forked, give slightly lower harvest in the end. And intriguingly, they often look the same, but when you come to harvest, the weight is not there. You know, that would be a fascinating study for anyone to do, I reckon. And also within this trial, I'm doing a no rotation trial. So the bed of broad beans you can see in the slide on the left and the potatoes, they are consecutive every year, broad beans, potatoes, and every year the broad beans are followed by cabbage, and every year the potatoes are followed by leeks. That's what you can see in the right-hand photograph. So it's 2 plantings a year, but every year it's the same 2 plantings in the same beds there. And again, the harvests have been fantastic. No obvious sign of going down. And you've got all these tables over those 8 years. I'm not going to dwell a long time. I haven't got time, I'm afraid. But, you know, if you really want to study this, there's a lot to learn there. And then another thing we found we can measure is bricks. So that's very easy with a handheld refractometer. They cost about £30, I think. And so I came across this video on YouTube, and this PhD guy was saying in no uncertain terms, you've got to have 12% bricks to prevent insect damage. So I thought, well, I don't think I've got 12. 12% is a lot, you know, that would be really sweet. If you look at the figures, we got like red onions 12, and apple, well, that was 15. A large beetroot was 11, interesting. But very few of the leaves were 12. So I don't know where he got that figure from. It's too general. And this is where I'm generally pretty wary of numbers. You've got to be careful how you interpret them, above all, even things like pH, and how pH varies around the root of the plant. You know, it's not like a global figure that applies to all of your soil. So don't get too hung up on figures. That would be certainly advice I'd give to, especially a lot of beginners who I find get quite daunted by it. And then this is looking ahead now. You know, what else can we find out? We're doing a lot of things that I still don't really know what they're doing, but I'm doing them anyway to see what results might be. And that on the left, that's a tower along the lines suggested by Philip O'Callaghan, energy tower, rather like the Irish round towers. I don't know if any of you know those. And it's alternating layers of organic and inorganic material inside clay, sets up a low frequency energy transmitter. You know, a little bit along the lines of maybe Avebury and Stonehenge, those monuments. Maybe that's transmitting some good energy to my garden, or maybe it's not. I don't know, and nor does any scientist, because we can't measure those energies yet. That's where we are. That's the limit that we have to acknowledge with science, and that's why I don't tolerate any scientist who tells me this is superstition. It's only because they can't measure it. You know, that's the word they use when they can't measure things. I'm certainly not anti-science, but I'm just anti that very narrow interpretation of it. There's a lot more to find out, and biochar is another one. And I met this guy recently, Connor Lascelles, who's invented that kiln for making charcoal, and it gives an exceptionally clean burn. It's not at all like the traditional old heaps of mouldering charcoal. So you've got air coming up between 2 cylinders of steel, and the burn is all at the top. It looks like the gas flame you have on a cooker. It's coming out really clean horizontally, and that burns off all the methane. So you've got very limited emissions. It's not smoking. And then what you have to do is when the burn goes down and down, and once it gets to the bottom, you've got to put it out before it burns the charcoal that's formed and would turn that into ash. So then we pour water on it, and then we've got our charcoal. And there's an example of doing something for the future. I haven't done that much yet, but we're going to use this in the compost heaps. So charge the charcoal and turn it into true biochar. I hope you've enjoyed this presentation. I now hand over to Hilary.